TypeScript 7 has officially been released, and after more than a year of painstaking development porting the compiler to Go, Bun proved that you can actually just do the entire thing with AI, so I'm sure the developers are happy about that. If you now run npm install TypeScript, you will get version 7, which is the version with the Go compiler. And following the announcement video from Microsoft a couple of days ago, I wanted to dive into exactly how they've achieved these massive performance gains. The results have been genuinely impressive. The new compiler builds the VS Code codebase, which is 1.3 million lines of code across almost 8,000 files in just 10 seconds, compared to the 125 seconds from the old compiler. And with TypeScript now proudly sitting as the #1 language on GitHub, believe it or not, the new compiler is going to change so many lives. I'm just getting emotional thinking about it. But rather than look at the almost identical features between 6 and 7, I wanted to dive into exactly how that performance is achieved. So let's take a look at the new compiler and see what makes it so fast. So why the rewrite? Well, the creator of C# and technical fellow at Microsoft, Anders Hejlsberg, said it quite plainly. JavaScript is optimized for UI and browsers. It's not really optimized for compute-intensive workflows and compilers, which is pretty obvious. Why? Because it's single-threaded, and processing something like an abstract syntax tree or type checking can only really scale so far with access to a single core. You could technically push work across workers, but then you'd need to serialize and deserialize the data, which is slow and memory intensive, and then you'd have to deal with the complexity of managing all of that. So they settled with Go, which provides dramatic performance improvements using a language that is basically fit for purpose. Go is a compiled language, which means we can run compiled code directly on the CPU rather than having to interpret it. And Go has a very good concurrency model, which means we can easily run multiple threads of execution at the same time, all with shared memory. This means we can take advantage of all the cores on your machine rather than just one. And there's roughly an even split. Up to half the speedup is attributed to being in native code, and the rest from having shared memory concurrency. Go is basically the perfect language for this. It's not just that Go is faster, it literally has more resources to throw at the problem, and the results speak for themselves. If we look at the numbers, VS Code at 1.3 million lines of code came in at 125.7 seconds on the old compiler, 10.6 seconds, which is 11.9x improvement. For Blue Sky, we've got 24.3 to 2.8, that's 8.7 improvement. And then for Playwright, we have 12.8 seconds down to 1.5, an 8.7 improvement. And funnily enough, it only takes 1 second to subscribe to BetaStack. Now, the gap here is only going to widen because cores are not really getting faster at the same rate they used to, but what we do get is more cores. I'm on an M3 Max, for example, which has 14 cores, which is insane. I remember building a gaming PC back in college, which had an Intel i7 with 4 cores, and I thought that was an absolute beast. The JavaScript compiler would just use one of those cores, but with Go, I unlock all of them. And of course, the more cores you have, the more performance you get. If I compile a large project on this machine in version 6, you'll see it takes 45 seconds. And with version 7, we can get that down to as little as 3 seconds. And there are multiple phases to the compilation process, and the type checking phase is just one of them. For this, Go will spin up 4 type checkers and have them check a quarter of the code base each, but you can actually improve that even further. So during compilation, you could set checkers to 12 for even faster performance. So I've downloaded the VS Code repo to my machine so we can see the difference between TypeScript 7 and 6. By default, TSC on my machine will now point to TypeScript 7. So we'll just run the diagnostics on this. And you can see that took 5.4 seconds, and the majority of the time was actually spent doing the check time, so 4.7 of those seconds. We can actually speed that up as well. So if we add another flag, checkers 12, so you can see the total time now has gone down from 5.4 to 3.5, and all of that shaves off the check time. So here we got 4.7, and then that's gone down to 2.9. Now let's run the same command again, but this time we're going to be using TypeScript 6, and this is going to take a little while, so we'll speed through it. So after waiting for that, you can see that TypeScript 6 finished with 45.3 seconds, compared to 3.5 that we get when we run across all the cores. So that is effectively a 15x improvement on my M3 Max chip. So for me, this is where the 3.5 seconds actually comes from. Doing this will of course steal performance from other processes, but if you're not doing anything, then you may as well use all the resources that your machine has. So let's take a look at some real code from the new compiler to understand how Go is able to achieve this performance. Here we have a bindSourceFiles function whose job is to build up every declaration in a file and work out what scope it belongs to. We're processing possibly thousands of files. We loop over each file, we queue up a function to bind it, then we wait for all of them to finish. The beautiful part is that we don't have to think about how that work gets distributed across cores. Go's runtime just handles all of that. We're not spawning threads or managing complex communication between cores. We just say, here's some work, and it figures out how to do the rest. In JavaScript, we could write almost identical code, but this is pointless for CPU-bound work. It would all still just happen on one thread in sequence, even if Promisor gives the illusion of parallelism. Workers are technically a way around this, but you can't share objects between them, only raw bytes with shared array buffer. So handing a parse syntax tree to a worker means serializing the whole thing and copying it across and rebuilding it on the other side. For a big file, that can cost more than the work itself. Basically, it's stuff like this that makes Go inherently better for CPU-bound work. It has a runtime that can handle all of this concurrency for you, and it has shared memory, so you can pass objects around without having to copy them. Now, aside from the compile time, the thing you're going to notice the most is the speed of your language server. Anyone who's worked on a large TypeScript codebase knows the pain of waiting for types to be type checked. And my God, these Intel Macs really felt this. I remember working on projects a couple of years ago, and you would open the repository and literally have to wait up to 2 minutes just to see the squiggly lines come in. And then every time that you made a change, it would just be incredibly painful. The developer experience is terrible, and then no one wants to work on the code base. The new language server, however, means instant feedback in your IDE, so you can open a file, make a change, and see the errors in literally milliseconds, even if you're working on potentially massive code bases. Aside from performance, the new language server is now more stable, so the need to restart your IDE when the type checking just stops working is drastically reduced. TypeScript 7 reduced failing language server commands by over 80% and reduced server crashes by over 60%. So that's less laptops thrown at walls, which is actually pretty good for the environment. So who knew Microsoft actually cared about the planet? Now, it's also worth mentioning this is a port, not a rewrite. So the TypeScript team have been very careful to ensure that the new compiler is basically fully compatible with the old one. You likely won't even notice a difference except for the speed. But whilst you can now run TypeScript 7 on your own projects, you'll still need to wait for your favorite packages to catch up. Their programmatic API is still missing, which means that any package that depends on that will need to wait for the 7.1 release. So packages like TypeScript ESLint, TSJest, or TSNode will lag behind. Now, the full release of TypeScript 7 is available for you to download, but you do need to explicitly install the TypeScript 7 extension for VS Code. The default package will eventually be updated, but for now, just install that extension. It's called TypeScript 7 on the extension store, and then everything will run as expected. If you want to see more about the feature set of TypeScript 7, we've filmed a video on exactly that you can see here. And if you enjoy breakdowns like this, then subscribe to BetterStack for more. So hopefully you learned something there, and now you can take advantage of the rapid development that you're going to get with TypeScript 7. I definitely know I'm going to enjoy using this one, but thank you for watching. And of course, I'll see you in the next one.